Okay, hello everyone. My name is Emily Collins, and today's presentation focuses on teaching fractions effectively to students with disabilities. I will discuss some evidence-based instructional strategies, practical accommodations, and ways to engage diverse learning styles, all of which tailored to help every student succeed in understanding fractions. Now, fractions are the mathematical concept that I have chosen for the sake of this presentation, but all of these methods will be able to be applied to most to all mathematical concepts and concepts outside of math. Okay, so some objectives. By the end of this presentation, you'll be able to define fractions in simple terms and understand the importance of using clear and concise, simple language when introducing new concepts. Understand effective instructional strategies such as CRA and explicit instructions, and identify appropriate accommodations and modifications as well as the difference between the two, and apply evidence-based practices that cater to visual, auditory, and kinesthetic learners. Okay, so the first thing that you'll do when introducing a new concept is very clearly and concisely giving a simple definition. So, what are fractions? Fractions represent parts of a whole. Understanding fractions means knowing the numerator and the denominator. The numerator indicates how many parts we have and is always represented by the top number, while the denominator tells us how many equal parts the whole is divided into, and the denominator will always be found on the bottom of the fraction. For students with disabilities, clearly visualizing these concepts through relatable real-world items like pizza slices or pie slices, or like I've chosen here, slices of watermelon, will greatly simplify comprehension and is a great method of incorporating authentic teaching in real-world examples. When students are able to relate the math to things that they know and use in their real life, they'll be more motivated to learn it, and comprehension will be aided tremendously. Okay, so instructional strategy number 1, CRA, concrete to representational to abstract. So the concrete to representational to abstract method, or CRA, is highly effective because it gradually guides the students from hands-on experiences to symbolic understanding. Students will first physically handle fraction manipulatives, like these fraction tiles that I have posted on the screen here, the top graphic, and finally transition to abstract numerical problems, which are like problems that you would see on a worksheet. For students with disabilities, this structured step-by-step method reduces confusion and reinforces learning at every stage. So first, the students will start with something concrete and kinesthetic, like the fraction tiles. Then they'll move on to something representational. A student drew the graphic that you see on the bottom that shows how each month of the year is representative of 1/12 of the year. And then they will move on to like actual problems on a worksheet. It's really important to check understanding throughout this process, as one could argue that from concrete to abstract, the methods of instruction go from easier to more difficult. It also benefits students with disabilities because it enhances their understanding through multiple modalities. So again, we're hitting lots of learning styles. We're also supporting some memory and retention of concepts through so many visuals. And we're providing a clear progression from easier to more difficult and more complex tasks. So here's like here's an example activity of the CRA method with fractions. Okay, so the problem that I've chosen here is 1/2 plus 1/4. Let's look at adding fractions using CRA. For example, 1/2 plus 1/4. First, students combine actual fraction tiles physically on their desk, clearly seeing and feeling the addition. So again, that would be like these top fraction tiles that I have here, the visual on the top. These are manipulatives that most special ed teachers will have in their classroom, or at least the ones who I have worked with. Whoops. Next, they will draw this in combination, visually confirming their understanding. So that's where the visuals like the pizza slices come in. We can see it visually represented, 1/2 plus 1/4. This is the representational phase of CRA. And lastly, they will write the problem numerically, which I have on the bottom here, solving it as abstractly as 1/2 plus 1/4 equals 3/4. This consistent progression ensures students internalize concepts fully. Okay, moving on to instructional strategy number 2, explicit instructions. So explicit instruction involves clearly defined objectives, modeling by the teacher, guided practice, and immediate feedback. Students with disabilities often thrive in structured environments where expectations are explicit, procedures predictable, and support consistently available. This clarity helps build confidence and prevents the repetition of mistakes by quickly addressing misunderstandings. This will also help keep up the students' confidence and reduce their anxiety, as immediate feedback prevents repeated errors. So, an explicit instruction example through teaching equivalent fractions. When teaching equivalent fractions explicitly, first, you will clearly state your objective, like with any other instructional strategy, going back to how the importance of clear and concise, simplified language. So, stating our objective. Today, we are identifying equivalent fractions. Then, the teacher will model visually, demonstrating that 1/2 is equal to 2/4, like I have with my pizza slices over here. Next, teachers will guide students as they practice matching visual and numerical fractions, like on a worksheet that I have also posted here, gradually moving toward independent practice. Once the student moves on to independent practice, after the teacher has already checked understanding and confirmed that they have built some sort of understanding over the concept, it will be integral that the teacher or para or whoever is responsible for monitoring the student's progress is giving immediate feedback. Immediate feedback is one of the most integral parts of explicit instruction. So, for example, during the independent practice, when the students are completing the worksheet or interactive activity independently, the teacher could say, do the first 5 problems and then raise your hand. After the student completes 5 problems, the teacher will check to see if the student has done so correctly. If not, they will return back to the whiteboard and do some more examples with the student on the board. If the student has mastered the first 5 problems, the teacher will give them some sort of praise and have them move on to the next 5, consistently checking back in to check for understanding, especially if it's the type of worksheet where concepts or wording of instructions changes slightly as you go through the page. However, the worksheet that I've included here on my slide is pretty consistent all the way down. So, accommodations and modifications in math. It is very important to note that accommodations and modifications are not the same thing. Accommodations do not change the content. So, modifications change the level or the quantity of the content. So, if a student is receiving accommodations, this may include extended time, the use of manipulatives or visual supports like charts or graphs. If the student is getting modifications, that means that their assignment has been changed or altered in the level of it or how much work they're actually doing. So they might have less problems than the rest of the class. They might have simplified fraction sets with smaller numbers. They might have more simplified directions and more clear language. Or they might have an alternate assessment entirely, like taking out written expression, for example. So this equivalent fractions chart that I have here would be a great example of an accommodation. Let's say that a student is taking an assessment on equivalent fractions. And a student with accommodations may be able to use an anchor chart like this for part or all of the test. An example of a modification can be found looking at the worksheet that we were using on the previous slide. If a student has completed half of this worksheet and they have demonstrated mastery of the content, as in they've gotten all or most of the problems correct, the teacher could omit the rest of the problems as a modification. The student has already showed mastery of the concept, and there'd be no reason for them to continue the worksheet if an appropriate modification would be reducing the number of problems that a student must do to earn their grade. Okay, evidence-based strategies from the text. So our textbook highlights the concrete representational abstract methods, explicit instruction, like we have previously discussed today. And it also highlights peer-assisted learning strategies, or PALS, to be proven effective. What I'm going to focus on here is peer-assisted learning. Peer-assisted learning helps students reinforce their understanding by teaching each other in structured settings, promoting social skills and academic achievement at the same time. I especially have found great success in peer-based learning. So this would be assigning students a partner who has higher understanding in the content area to help explain problems to them or work together with them. Or let's say the class is doing a Kahoot over fractions. This would be a good time to utilize a peer tutor for that student as well. Okay, let's talk about differentiation by learning styles. Students absorb information differently, so differentiating instruction is definitely key. Visual learners understand best through diagrams and fraction visuals. Auditory learners may respond effectively to verbal explanations, mnemonic devices, rhythmic chants, or songs, which for most mathematical concepts, there are songs available on YouTube, including fractions. Kinesthetic learners engage deeply through hands-on activities and physical involvement, like with our fraction tiles. Catering to these preferences ensures every student maximizes their potential to learn fractions or any concept successfully. For visual learners, fraction bars would visually Would also visually illustrate comparisons and equivalencies clearly. Auditory learners could benefit in the mnemonic sense from catchy fraction songs or chants. And kinesthetic learners could actively engage in activities like fraction scavenger hunt, physically finding fractions represented in everyday items or just taped around the classroom. These are all differentiated activities that ensure that all students remain motivated and connected and engaged with the lesson. Okay, formative assessment and progress monitoring. Formative assessments provide real-time insights into student understanding. Simple checks for understanding, like exit tickets or thumbs up, thumbs down signals, can quickly gauge comprehension. Incorporating manipulatives into assessments accommodates diverse needs, giving clear indications of actual understanding. Regularly reviewing this progress data helps educators adjust instruction dynamically, providing targeted interventions and ensuring consistent academic growth in all students. So, technology integration. Technology further supports fraction instructions, providing varied access points. Virtual manipulatives on apps like SplashLearn simulate concrete fraction experiences digitally. Interactive whiteboards can create visually stimulating lessons that enhance student engagement. Assistive technologies like text-to-speech or magnification software can ensure accessibility, engaging all learners, especially those with disabilities, to confidently access curriculum content and demonstrate learning effectively. One of my favorite types of technology integration, however, is the use of games. And students generally enjoy playing the games as well. I like to integrate technology as an early finisher in regards to games. When students finish an assignment, they can be allowed on these educational games, and it's almost like they forget that they're learning. To summarize, effective fraction instruction for students with disabilities includes CRA methods, explicit instruction, and targeted accommodations and modifications, and differentiated instruction tailored to various learning and styles, formative assessment to guide instructional decisions, and thoughtful technology integration. All of these components work together across teaching all concepts to students with disabilities, forming a comprehensive approach that ensures all students achieve a meaningful understanding of all concepts, including fractions. Thank you for listening.